Santorini is shaking itself apart. 28,000 earthquakes in 30 days. The most violent seismic crisis to strike Greece's most famous island in 75 years, and it is not stopping. And what scientists just discovered beneath those tremors has volcanologists more alarmed than at any point since modern monitoring began. This is not ordinary tectonic activity. This is something far more dangerous. 11,000 people have fled the island. Schools are closed across 4 Aegean islands. The old port of Thera is sealed off behind barricades. Ferries packed with terrified residents pull away from docks that tremble every 10 minutes. Families with young children sleep in parked cars because they cannot trust the walls around them. 129 earthquakes above magnitude 4.0 in less than 2 weeks. The strongest registering magnitude 5.2, the most powerful tremor to strike Santorini since 1956. That year, a magnitude 7.7 earthquake leveled the island and sent a 25-meter tsunami crashing across the Aegean Sea. It was the largest earthquake to hit Greece in the entire 20th century. 53 people died. 529 homes were destroyed outright. 35% of every building on Santorini collapsed in a single morning. And here is what that actually means for the current crisis. A sheet of molten rock is slicing upward through the Earth's crust at a depth of 18 kilometers, rising in pulses toward the seafloor, not cooling, not retreating, ascending. The earthquakes are not the threat, they are the symptom. Each one marks the moment when rising magma fractures another section of bedrock on its way toward the surface. But here is what has volcanologists in complete disbelief. The magma is not coming from Santorini's own Caldera. It is surging from a shared reservoir that connects Santorini to Colombo, a submarine volcano sitting just 7 kilometers offshore. 2 volcanic systems that scientists believed operated independently are now feeding from the same deep source. The last time Colombo erupted in 1650, it killed dozens and sent a tsunami racing across the Aegean. Before that, Santorini produced one of the largest volcanic explosions in human history, an eruption so powerful it contributed to the collapse of an entire civilization and may have inspired the legend of Atlantis. Is Santorini's earthquake swarm the final warning before a volcanic eruption that could devastate the eastern Mediterranean? Or has the magma already lost its momentum, sparing 3 million annual visitors from the same force that destroyed the Minoan world 3,600 years ago? As of late February 2025, the National Observatory of Athens maintains heightened seismic monitoring across the Santorini-Amorgos fault zone. A state of emergency declared on February 6th remained in force through March 3rd. The declaration followed the strongest tremor in the swarm, a magnitude 5.2 earthquake that sent shockwaves through Santorini's Caldera cliffs and triggered landslides above the village of Thera. The numbers tell a story of relentless escalation. Seismic stations recorded over 28,000 individual earthquakes between late January and the end of February. Of those, 129 exceeded magnitude 4.0. Hundreds were strong enough to be felt by residents, arriving every 10 to 20 minutes during peak activity. Seismicity bursts occurred almost twice daily, each cluster lasting 1 to 2 hours. The shaking was not constant, but it was unceasing. Every quiet interval ended with another pulse. Satellite-based interferometric synthetic aperture radar detected approximately 45 millimeters of uplift inside the Santorini caldera beginning in July 2024. That is nearly 2 inches of ground inflation concentrated above a shallow magma reservoir at a depth of 3.8 kilometers. It is the same reservoir that swelled during the 2011 Unrest crisis and that has been recharging in pulses since at least 2011, accumulating approximately 0.024 cubic kilometers of fresh magma across 3 documented episodes. None of those earlier pulses triggered an eruption. None of them produced anything remotely resembling the seismic violence of 2025. Earthquake focal depths migrated upward during the swarm. Tremors began at 18 kilometers beneath the surface and rose in pulses to as shallow as 3 kilometers. That is a vertical ascent of 15 kilometers in a matter of weeks. The migration pattern was not random. It traced the path of ascending magma through fractured crust with a precision that left researchers staring at their screens in alarm. Carbon dioxide and hydrogen gas emissions increased inside the caldera in the months preceding the swarm. Chemical signatures shifted, the source was deepening, fresh magmatic material was entering the system from below, and the surface was responding before the earthquakes even began. Ground deformation data confirms what scientists feared most. The pressure beneath Santorini is not static, it is actively redistributing through a volcanic plumbing network more complex and more interconnected than anyone previously understood. July 2024, GPS stations inside the Santorini caldera detect the first signs of renewed inflation. Satellite data shows the northern caldera floor rising at measurable rates. Scientists at the National Observatory of Athens note the similarity to patterns observed during 2011 Unrest, when 14 centimeters of uplift over 14 months triggered international concern before the system eventually quieted. Monitoring intensifies. No public alerts are issued. The uplift goes largely unnoticed outside the scientific community. By December 2024, cumulative ground deformation reaches 45 millimeters. Carbon dioxide flux increases from fumaroles on Nia Kameni, the small volcanic island sitting in the center of the caldera where tourists hike to peer into steaming vents. The chemical data suggests magma is recharging the shallow reservoir at approximately 3.4 kilometers depth. Researchers from the GFZ Helmholtz Center for Geosciences in Potsdam begin analyzing satellite data alongside Greek colleagues. The numbers are concerning but not yet alarming. Santorini has done this before. January 24th, 2025. The first cluster of earthquakes registers between Santorini and Amorgos. Over 380 tremors are recorded in the following week. Magnitudes remain moderate. Scientists debate whether the activity is purely tectonic or carries a volcanic signature. The uncertainty is agonizing. Santorini sits at the intersection of active faults and an active volcanic system. The earthquakes could mean the crust is adjusting to normal tectonic stress, or they could mean something is forcing its way upward. The data does not yet distinguish between the two. January 27th, 7 p.m. UTC. The seafloor northeast of Santorini begins shaking violently. The swarm intensifies within hours, producing thousands of earthquakes per day. Epicenters migrate northeast, moving more than 10 kilometers away from the caldera toward the submarine volcano Colombo. The pattern defies initial tectonic explanations. Tectonic swarms do not migrate in a coherent direction at increasing depth. Something is driving this sequence from below. February 1st through 3rd. Over 200 earthquakes are recorded in 48 hours, including 7 exceeding magnitude 4.0 on a single day. Residents describe shaking every 10 to 20 minutes through the night. Hotels drain swimming pools on government orders to reduce structural stress on buildings. Schools close across Santorini, Amorgos, Ios, and Anafi. Fire brigade rescuers arrive by helicopter and establish a staging area in a basketball court next to the island's main hospital. Yellow tents go up. A rescue dog arrives with a 26-member search and rescue team. The sight of those tents tells residents everything the official statements do not. February 3rd shatters earlier projections. Hundreds of tourists and residents flood Santorini's port, scrambling onto ferries bound for Athens. Aegean Airlines adds 3 emergency flights. The Greek Prime Minister addresses the nation from Brussels and says, "We have a very intense geological phenomenon to handle. I want to ask our islanders to remain calm and follow the instructions of civil protection." Calm is not what people feel when the ground shakes beneath their feet every few minutes. February 6th brings the earthquake that changes everything. A magnitude 5.2 tremor, the strongest in the entire swarm, courses through the region. It is the most powerful earthquake to strike near Santorini since the catastrophic 7.7 magnitude event of 1956. The Greek Civil Protection Ministry declares a formal state of emergency, effective until March 3rd. Coastal areas are ordered evacuated immediately if stronger earthquakes occur due to tsunami risk. The word tsunami appears in an official Greek government communication regarding Santorini. That has not happened in modern memory. By mid-February, the British Geological Survey deploys machine learning algorithms that detect 10 times more earthquakes than standard seismographs can identify. The true count crosses 20,000 and keeps climbing. Dr. Margarita Segu, leading the BGS analysis, describes pulses of seismicity arriving almost twice daily. This swarm is fluid-driven. The earthquakes are not caused by tectonic plates grinding against each other. They are caused by pressurized fluid, magma, and superheated water forcing their way through rock. Week 4 brings the number that alarms the international volcanological community. 28,000 earthquakes were recorded. Research institutions from Germany, Britain, the United States, and Greece converge on the data. Ocean bottom seismometers deployed at Colombo as part of the German-Greek Multi-Marex project detect pressure changes on the crater floor. Colombo's seafloor subsides by 12 to 32 centimeters. The submarine volcano is deflating. Its magma is going somewhere else. The critical unknown remains unchanged since day one, where that magma stops, and whether the next pulse will carry more pressure, more volume, and more momentum than this one did. Earthquakes are the crust's confession. When magma forces its way through solid rock, the rock does not bend quietly, it shatters. Each fracture registers as a seismic event. Track those events in sequence and they trace the path of ascending molten material like footprints through fresh snow. The faster the footprints appear, the faster the magma is moving. Dr. Marius Iskin, a geophysicist at the GFZ Helmholtz Center for Geosciences, describes the mechanism in precise terms. The seismic activity was typical of magma ascending to the Earth's crust. The migrating magma breaks the rock and forms pathways, which causes intense earthquake activity. His team traced the path and dynamics of the magma ascent with unprecedented accuracy using a combination of land-based seismic stations, ocean bottom instruments, and satellite data. The discovery upended assumptions that had stood for decades. Santorini and Colombo, separated by just 7 kilometers of Aegean seafloor, were studied as independent volcanic systems. Their shallow magma reservoirs showed distinct chemical signatures. Petrological evidence indicated separate mantle sources. Scientists treated them as neighbors, not partners. Textbooks described them that way. Monitoring budgets were allocated that way. Emergency plans were designed that way. The 2025 crisis proved them wrong. The data shows a vast curtain of magma known as a dike rising from a mid-crustal reservoir that sits beneath both volcanoes. The dike propagated northeast, slicing horizontally through the crust at depths greater than 10 kilometers. If the dike were a knife pushing through bread, the blade would be pointing downward, but the knife would be moving sideways. The sheet of molten rock traveled laterally, fracturing everything in its path and generating thousands of earthquakes as it went. Compare this to the 2011 Unrest, when Santorini's shallow reservoir inflated by approximately 14 centimeters over 14 months. That event involved modest inflow rates of 0.3 to 0.6 cubic meters per second and produced low magnitude earthquakes that never exceeded magnitude 3.2. The 2025 intrusion involved a fundamentally different scale of magmatic mobilization. The dike originated deeper, traveled farther, produced earthquakes exceeding magnitude 5 and affected 2 volcanic centers simultaneously. This was not a gentle recharge, this was an intrusion. Dr. Stephen Hicks of University College London explains the analytical breakthrough that confirmed the volcanic origin. His team treated each of the 25,000 precisely located earthquakes as virtual stress meters, clues revealing how underground pressure was changing in real time. The method ruled out fault slippage as the primary cause and confirmed magmatic intrusion as the driving mechanism behind the entire swarm. As the dike rose through the crust, both volcanoes responded in tandem. Santorini, which had been inflating since July 2024, began to subside. Colombo's crater floor dropped by up to 32 centimeters. The shared mid-crustal reservoir was bleeding molten rock into the ascending dike. The pressure was redistributing across the entire system. Two volcanoes were deflating simultaneously because a single intrusion was draining their common source. The dike rose from 18 kilometers depth to as shallow as 3 kilometers beneath the seafloor in just weeks. Iskin acknowledged the terrifying implication during the publication of results. There was a possibility that magma would reach the shallow seafloor, which could cause explosive activity. Superheated magma meeting cold seawater produces PIH magmatic explosions. It is the kind of explosion Colombo produced in 1650 when its last eruption killed dozens. The health consequences rippled across the Cyclades even without an eruption. Elevated carbon dioxide and hydrogen sulfide emissions from Caldera fumaroles triggered respiratory complaints among residents who remained on the island. Volcanic gas concentrations spiked in enclosed spaces near fumarolic vents. The invisible chemical threat accompanied every visible tremor. The numbers represent families. 11,000 people fled Santorini in a matter of days. Behind every departure stands a person who packed a suitcase not knowing if their home would still be standing when they returned. Kostas Sakavaras, a tourist guide who has lived on Santorini for 17 years, left the island on a packed ferry with his wife and 2 children. He told reporters he had never experienced this level of seismic activity before. He said it was shaking every 3 to 4 hours yesterday. This felt different from the other times. He planned to stay on the mainland until the end of the week. His livelihood, built over nearly 2 decades of guiding visitors through whitewashed villages and caldera sunsets, sat empty behind him on an island he could not trust. Michalis Gerontakis, the director of the Santorini Philharmonic Orchestra, described the psychological toll with quiet precision. He said he had never felt anything like this, and with such frequency. An earthquake every 10 or 20 minutes. Everyone is anxious, even if some of us hide it not to cause panic, but everyone is worried. The night before he spoke those words, his orchestra performed at a church for a religious occasion. The musicians could not feel the earthquakes while they played. The earthquakes came anyway. They always came. Children carry the invisible wounds. Schools across 4 islands closed indefinitely. Families with young children slept in parked cars through February nights, afraid to remain inside buildings that cracked a little more with each tremor. Some families camped outdoors despite winter temperatures. A fire brigade rescuer confirmed that entire families spent nights outside, unable to sleep indoors. The staging tents at the hospital basketball court were meant for rescue personnel. They became a symbol of an island preparing for the worst. Mental health teams from the Hellenic Red Cross conducted emergency interventions. 198 residents received psychological first aid training in sessions held across multiple communities in coordination with municipal authorities and local security forces. Counselors visited elderly care centers and vulnerable populations who could not evacuate. The Red Cross performed evacuation drills at the island's senior care facility. The drill was precautionary. The fear it addressed was not. The economics are devastating and compounding with each day the crisis continues. Santorini draws more than 3.4 million tourists annually. The island's whitewashed villages perched along dramatic caldera cliffs generate revenue that sustains 20,000 permanent residents through hotels, restaurants, boat tours, and the cruise ship industry. The earthquake swarm struck during the low season, but cancellations cascaded forward into spring and summer, the months that determine whether a business survives. The US Embassy issued travel warnings. The UK followed. International media broadcast images of empty streets and fleeing crowds to audiences worldwide. For an island whose economy runs entirely on the perception of paradise, those images were their own kind of catastrophe. Property owners discovered that earthquake insurance in Greece excludes many forms of seismic damage. Structural assessments revealed cracks spreading through buildings that had survived decades without incident. The Caldera cliffs, which give Santorini its iconic beauty, became the source of its greatest danger as rockfalls closed the old port of Thera and the seaside areas of Amudi and Armeni. The volcano decides when Santorini reopens for business. The fault decides when families go home. Historical record haunts every scientist monitoring Santorini's current activity. This island has destroyed civilizations before. Approximately 1600 BC, the Minoan eruption of Thera ranks among the most catastrophic volcanic events in human history. It reached a volcanic explosivity index of 7. Between 28 and 41 cubic kilometers of material were ejected into the atmosphere. To understand that scale, the 2022 Hunga Tonga eruption, which sent shock waves around the planet, was roughly 1/10 the size of this ancient eruption from the same volcanic chain to which Santorini belongs. The Minoan blast sent superheated pyroclastic flows racing across the water at 300 kilometers per hour. Tsunamis reaching 35 meters slammed into the northern coast of Crete, 118 kilometers to the south. The eruption buried the thriving Minoan settlement of Akrotiri under meters of pumice, preserving it like a Bronze Age Pompeii. Frescoes, pottery, and multi-story buildings were frozen in the moment of destruction. The absence of human remains suggests residents evacuated before the final blast. They escaped the mountain. They did not escape its consequences. The Minoan civilization, the dominant power in the Mediterranean and the first advanced civilization in Europe, never recovered. Tsunamis destroyed their naval fleet. Volcanic ash disrupted agriculture across the eastern Mediterranean for years. Cold summers devastated harvests. Within decades, the Mycenaeans from mainland Greece conquered what remained. Some historians believe this catastrophe inspired the legend of Atlantis, a civilization swallowed by the sea in a single terrible day. The caldera that tourists photograph today is the wound left by that eruption. The crescent-shaped island, the sheer cliffs, the submerged crater filled with Aegean water, all of it is a scar from the last time Santorini erupted at full force. Fast forward to 1950. Santorini's last confirmed eruption produced lava flows from Nea Kameni, the volcanic island inside the caldera where tourists now hike past steaming vents and buy souvenirs. The event was relatively small, but it confirmed what geologists already knew. The system beneath Santorini remains active. The magma chamber is not extinct, it is recharging. 6 years later, catastrophe arrived from a different direction. On July 9th, 1956, at 5:11 a.m. local time, a magnitude 7.7 earthquake struck the sea south of Amorgos. It was the most powerful earthquake to hit Greece in the entire 20th century. 13 minutes later, a magnitude 7.2 aftershock struck near Santorini itself. A tsunami with waves reaching 25 meters crashed into the southeastern coast of Amorgos. 53 people died. Over 100 were injured. 529 homes were destroyed outright. Another 1,482 suffered severe structural damage. Almost every public building on Santorini was leveled. Contemporary reports describe the tremor as equivalent to the explosion of 10,000 atomic bombs. The destruction triggered a mass exodus that reshaped Santorini's demographics for a generation. Santorini's population migrated to Athens in waves. The island nearly emptied. Entire villages were abandoned. It took decades for residents to return and decades more to rebuild the terraced architecture that now defines the island's silhouette against the Aegean sky. The comparison to 2025 is what keeps seismologists watching their instruments through the night. The current swarm occupies the same fault zone, the same Santorini-Amorgos corridor, and the same underwater terrain that generated the largest Mediterranean tsunami in 2 centuries. A 2024 submarine survey using autonomous underwater vehicles discovered the actual fault scarp from 1956, revealing seafloor offsets of 9.8 to 16.8 meters along a 75-kilometer rupture. The fault that produced the 20th century's worst Aegean disaster is not a historical curiosity. It is a physical structure sitting beneath the same water that shook 28,000 times in February 2025. And the 2025 crisis adds a variable that 1956 did not have. Active magmatic intrusion was occurring from below. The Greek government activated its full crisis apparatus within days of the swarm's intensification. Prime Minister Kyriakos Mitsotakis convened an emergency meeting of top officials and scientific advisors. The whole state mechanism has been activated. I want to urge our citizens to cooperate with the authorities. Fire service rescue teams deployed to Santorini on February 2nd. A 26-member unit with search and rescue capabilities established a staging area adjacent to the island's main hospital. Military and civil protection forces repositioned across the affected Cycladic islands. The Ministry for Climate Crisis and Civil Protection issued alerts through the emergency number 112, banning public access to Amudi, Armeni, and the old port of Thera because of rockfall hazard along the Caldera cliffs. Hotels received orders to drain swimming pools. Citizens were advised to avoid large indoor gatherings, abandoned buildings, and island ports. Aegean Airlines added 3 emergency flights between Santorini and Athens. Ferry operators increased departures. On February 3rd alone, hundreds of passengers crowded the main port, boarding vessels bound for Piraeus. High winds on February 5th grounded ferries entirely, trapping evacuees on an island that would not stop shaking. The municipality of Thera published an updated civil protection plan designated Theras 2, detailing emergency shelters across all 8 sectors of the island, evacuation routes, pickup points for vulnerable groups, and airdrop zones for humanitarian supplies in the event of a full-scale disaster. The UNESCO Intergovernmental Oceanographic Commission activated coordination protocols through the Tsunami Early Warning System for the Mediterranean. A direct communication channel was established between the Hellenic National Tsunami Warning Center and Turkey's Kandili Observatory for rapid information exchange during nighttime hours and weekends when staffing is thinnest. International monitoring intensified. The British Geological Survey deployed machine learning analysis. The GFZ Helmholtz Center provided real-time seismic processing. GeoMars ocean bottom instruments at Colombo fed pressure data to researchers across Europe. The scientific mobilization reflected the scale of concern, but one honest limitation echoed through every briefing. The Mediterranean Tsunami Warning System handles seismic-driven tsunamis. It was not built for volcanic tsunamis, submarine landslides, or caldera collapse events, the kinds of events this region has produced before. Efforts to address that gap were underway. They were not complete. Scientists monitoring the Santorini-Colombo system modeled 3 possible trajectories for the crisis. Each carries different implications for the 20,000 permanent residents, the 3.4 million annual tourists, and the broader eastern Mediterranean. Scenario 1 offers cautious relief. The magmatic dike loses momentum before reaching the sea floor, seismic activity gradually declines, and the shallow reservoir stabilizes without further intrusion. This is what occurred during the 2025 crisis. Most dike injections failed to cause eruptions, and this one was no different. The magma lacked sufficient pressure and buoyancy to breach the surface. The crisis ended without eruption by late February, but scientists are explicit. This outcome does not eliminate the threat, it delays it. Scenario 2 projects a future intrusion that succeeds where this one failed. The shared mid-crustal reservoir beneath Santorini and Colombo recharges. A new dike propagates upward with greater volume and pressure. This time, magma reaches the shallow sea floor near Colombo, and an underwater eruption produces explosive magmatic activity as superheated magma meets seawater. The 1650 eruption of Colombo killed dozens and generated a tsunami from precisely this mechanism. A repeat event would threaten every coastline within 100 kilometers. The eastern Mediterranean has no modern experience managing a submarine volcanic eruption of that magnitude. Scenario 3 represents the nightmare that haunts every volcanologist studying this region, a major eruption from the Santorini caldera itself. The Minoan eruption of 1600 BC reached volcanic explosivity index 7. It ejected up to 41 cubic kilometers of material. It generated tsunamis that devastated coastlines across the eastern Mediterranean. It contributed to the collapse of a civilization. Dr. Efthymios Lekas, head of the Scientific Monitoring Committee for the Hellenic Volcanic Arc, offers a timeline that provides cold comfort. He says the Santorini volcano produces very large explosions every 20,000 years. It has been 3,600 years since the last explosion, so we have a very long time ahead of us before we face a big explosion. The math is reassuring on geological timescales. It is meaningless to the family sleeping in their car tonight because their house cracked again. A compounding threat that few discuss publicly is clear. The 1956 Amorgos earthquake demonstrated that seismic events in this corridor trigger submarine landslides. Landslides generate tsunamis that arrive at coastlines within minutes. A major eruption accompanied by caldera collapse would displace billions of tons of seawater in an enclosed basin surrounded by inhabited islands. Cruise ships carrying thousands of passengers anchor inside the caldera every summer. Warning time for a caldera-generated tsunami could be measured in single digits of minutes. No evacuation plan accounts for that. 28,000 earthquakes, 11,000 evacuees, a sheet of magma that rose from 18 kilometers depth to 3 kilometers beneath the sea floor in a matter of weeks. A shared volcanic reservoir connecting two explosive systems that scientists studied separately for decades. The most violent seismic crisis to strike the Aegean since 1956. These are the numbers that define Santorini's awakening. None of them guarantee what comes next. In apartments across Athens and Piraeus, families from Santorini check seismic monitoring apps before sunrise. Kostas Sakavaras calculates how many weeks of lost tourist season his family can absorb before the math breaks. Mikalis Gerontakis wonders when his orchestra will perform again in a church that does not tremble beneath their feet. Children who slept in cars ask their parents when the shaking will stop. The parents do not have an answer. At monitoring stations positioned across the Cyclades and on the seafloor near Colombo, instruments record data streams that never pause. Seismographs trace every tremor. Ocean bottom pressure sensors measure every centimeter of seafloor displacement. Machine learning algorithms detect earthquakes too small for conventional instruments to catch. The surveillance never sleeps, but surveillance cannot control what the Earth decides to do next. The impossible truth that has defined life on Santorini for 3,600 years remains unchanged. The same caldera that threatens annihilation is the reason anyone lives here at all. The dramatic cliffs that crumble during earthquakes are the cliffs that draw 3 million visitors a year. The volcanic soil that could bury the island grows the Assyrtiko grapes that produce wine found nowhere else on Earth. Beauty and destruction occupy identical coordinates. The geography permits no compromise. Yet communities endure. Santorini rebuilt after 1956, transforming earthquake rubble into the whitewashed terraces that became the most photographed landscape in the Mediterranean. Residents returned. Businesses reopened. Life resumed on the rim of a caldera that has erupted catastrophically before and will erupt again. The resilience is not ignorance of danger. It is clear-eyed acceptance that this island is home despite everything it threatens to take. The 2025 crisis revealed something new. Santorini and Colombo breathe from the same deep source. Their magmatic plumbing is coupled at depth. What affects one affects the other. The models built on assumptions of independence no longer apply. Scientists who spent careers studying these volcanoes separately now scramble to understand how they behave as one. Whether the next intrusion reaches the surface or stalls harmlessly in the crust remains unknown. The reservoir beneath both volcanoes continues. recharging on timescales that make human calendars irrelevant. The faults that generated the largest Mediterranean tsunami of the 20th century remain active, their rupture scars mapped on the seafloor in detail for the first time just months before the swarm began. The geological machinery operates with or without an audience. Tonight, the Santorini caldera glows under a Mediterranean sunset. The water inside the crater shifts from cobalt to amber as the light fades. Cruise ships will return to anchor inside that crater by summer. Tourists will photograph the same cliffs that shed boulders onto sealed roads just weeks ago. They will sip Assyrtiko wine on terraces overlooking the caldera and post images to social media celebrating paradise found. The whitewashed villages will fill again with visitors who see beauty without seeing what lies 4 kilometers beneath their feet. Beautiful, fragile, patient. The same island that inspired the legend of a lost civilization now waits to see if the forces that created it will return. The earth beneath the Aegean shifts in increments too small to feel but too constant to ignore. The volcano that destroyed Thera 3,600 years ago is not extinct, it is recharging, and the 20,000 people who call this caldera home understand something that 3 million annual visitors never will. The shaking stopped, the magma did not leave, and the question that haunts every seismologist watching this stretch of sea grows harder to dismiss with each new pulse of data from below. Santorini's beauty is borrowed time. The only question is how much remains.